Hello everyone, I am Anshul Gupta and I am here to showcase you my IBM Advanced Data Science Capstone project that I have made during this course of 4 weeks on true news versus fake news. So moving on to the use case and the dataset that I have chosen, overview of the use case. So what my use case is basically to visualize, classify and predict whether a news is true or fake based on the given dataset. So my motivation was for choosing this use case was that there's a lot of fake news spread in this corona times, and I have been working on how these social media sites classify whether a news is a spam message or not, or how these their algorithms work. So it's a quite interesting topic to work upon, and I have carried it forward through my algorithms and through my knowledge of machine learning and deep learning, and try to provide a solution to it. So let's move on to the dataset. So basically, the dataset is provided by Clement Basalian at Kaggle. You can go through this site and you will find the datasets. It consists of two files, that is fake news as fake.csv, and the other one is for the true news as true.csv. And the datasets are of um, quite larger, not quite big, but around 55 to 60 MB of each of the dataset is there, and below is a solution that I have provided, you and you will find it quite interesting after you have seen the visualizations as well. So moving forward to my solution, first I have visualized each and every column, how they're working, how they're related to each other, their uh, visualizations, and especially when you're working on a binary classification problem, either it is to be or not to be, as in this case that I have included from my visualizations, it becomes very important how each column is uh, related to your output predictions. And using this visualizations, I have further vectorized the text, and before vectorizing, I have cleaned a whole of the textual data that was there, and thereafter vectorized the textual data in different ways, so that before feeding to the model, we have something called dimensions in our case. And I have used three basic models that is logistic regression model, number one. The second one is decision tree classifier, the model with the decision tree classifier, and the third one is a simple artificial neural network. And the best accuracy and the F1 score in this case that I got was with the decision tree classifier. Uh, that gives me an accuracy of around 99.63% in classifying fake and true news. Also, it gives me an F1 score of 99.61%. So basically, accuracy provides me a measure of true positives and true negatives. That is, and that is it. And the F1 score provides me an F that how the false positives and false negatives are recognized. Basically, it is a weighted average of precision and recall uh, of our uh, model, right? So the complete solution is attached as a notebook over here, and I'll be sharing it with you in the description as well. But moving forward, I would be sharing how the visualizations, how each process I have used, and what technologies I have used, what uh, data quality assessment steps, or what exploration steps, or what model I have chosen and why I have chosen it. So let's move forward. Uh, so I would first of all like to thank IBM Watson Studio for providing me a platform where I can work uh, and uh, do my uh, predictions for this process or for this model. So first of all, the process I'll go line by line. That was first I will talk about the ETL process, then feature engineering. Thereafter, we will deal with the model definitions as well, and finally the model predictions or the evaluations that I did. So first of all, the ETL process. Here the tools that I have used are Pandas data frames and Python, and uh, I have extracted, first of all, loaded the data to the cloud storage. From there I have extracted it to my notebook and then converted it in each into, like, there were two data sets for fake and true, and I have each converted it into pandas data frame. You can see here df underscore data underscore one is for the fake news fake.csv, and for true.csv we have created another data frame that is df underscore data underscore true 2. And thereafter I have concatenate, first of all added an additional column so that we can work on a single table, and to each of these df underscore data underscore one that was for the fake news, I have added an additional column is fake or is true and set it to 0, set its value to 0 for each row, and then thereafter is fake or is true is set to 1 for the true news dataset for each row. And thereafter I have concatenated uh, every uh, row of df underscore data underscore 1 and df underscore data underscore 2 side by side, basically one over the other. And we have around 44,898 rows and 5 columns by now, after we are done with this process and concatenation process, right? So moving on to the data explorations and visualizations that I used. First of all, the tools used were Matplotlib, Seaborn, and Python. Basically, Matplotlib and Seaborn provides me an upper edge of on the visualizations, and with minimal coding skills, I can get quite good visualizations of the columns or of the titles or of anything, the textual data I wish and to visualize, and these give me an awesome visualizations. So moving on to the data exploration. So basically, first of all, I checked if there is any missing or null values in my dataset, and I found that my dataset is mostly complete and does not have any missing values over here. So you, as you can see, none of the column is having any null value, right? And thereafter, moving on to the visualizations that I did. First of all, you can see the distribution of the fake news and the true news. So there are around 20,000 of the true news, and the fake news count is approaching 25,000. So making it a total of 45,000 rows. And so we can say this, that it's an uneven kind of uh, distribution, but almost similar count is there in the distributions. So as we had the 5 columns over here: title, text, subject, date, is fake or is true. So here I have visualized the date column first of all, and came to a conclusion that most of the fake news are published in the month of May, and the true news varies from September to December 2017. Uh, but you can clearly see on these bases that on a particular date basis, I cannot predict whether it's going to be a true news or a fake news. So I need certain facts and figures on basis of which so I can predict whether it's going to be a true news or fake news. So using this knowledge of mine, I have neglected the date column and thereafter moved forward to the subject column. So this is the uh, count plot of the subject that we are having. So news, we are in the case of fake news, we are having the subjects as news, politics, government news, left news, US news, Middle East, and in case of true news, we are having only politics news and world news. Here, one thing I want you to notice that uh, there's no name in the subject of true news matching to that of the fake news. So I can predict with a quite good accuracy for my this data set, but it would fail for the unseen data, or you can see the testing data that we will feed if I take subject as my primary column for making future predictions. So on this basis, I neglected the subject column and thereafter moved forward to the title and the text column that were left. So here you can see the visualizations of the title column based on the length. You can see a distance plot and a box plot of the length of the words. And by this, we get to know how the length of the title is varying in case of fake news and in case of a true news, and how the length of the words is varying from a fake news to a true news. And mostly we can say the fake news are comparatively having more length in the title as well as in case of words, but the true news are having less in case of title column. So here also visualizing once again the top 100 words, or you can say the most used words in case of a fake news were these as I have plotted, and the unique I forgot to mention it is for the column title column and the fake news, the most used words and the titles of the fake news. So here you can see two. The thing that I want you to note here is the repetitions or the duplicacies we are having in the data before I move to the cleaning step. What I noticed. So you can see two over here, you can see two over here. They are basically the same meaning, but having different counts. As you can see, this two is having around 8,000 of count, and this is having around 1200 count, but they are of the same meaning. And so these need to be removed. And further moving on to those of the true news, here also two is used most number of the times, but all you can see is that these are basically stop words that I am showing you. So thereafter, moving on to the text column visualizations, these were similar to what we did for the title column based on the length and based on the words, and came to the predictions, or you can say conclusions for this was that length text length for a fake news are comparatively longer, but on this basis we cannot say whether it's going to be a fake news. But when I saw the most used words, so there were a lot of stop words coming over and over again. And before moving on to the data cleaning, this was the important step that I realized that we need to remove the stop words as well. So basically what the stop words are, the useless words that make our data a bit, uh, you can say, uh, this is some sort of useless data that we are having and we need to remove it. Also, you can see punctuations. You will be able to see punctuations over here in the title column, and we need to remove those as well. So these three things before moving on to the data cleaning I visualized, and you can see punctuations over here as well in quite good number of around thousands and 1200. So these need to be removed as well. And moving on to the data cleaning part, The tools that I have used is Natural Language Toolkit, basically used for natural language processing, and it makes our work quite easier. And then the string library, and of course the programming language is Python. So first of all, I created a function for the three things that I mentioned before, that is removing the punctuations, converting everything to either lowercase or uppercase. I have chosen for the lowercase, and removing stop words using this. So basically these three things that I have done for the data cleaning. Of course, there are other ways as well, but uh, I chosen the basic three things because I didn't want to lose the useful data uh, in case of adding more complexities to it, right? So after data cleaning, I concatenated both the clean title and the clean text. So first of all, before concatenating, I would like to tell you that both the columns, title and text, were passed to this function so that these are removed. And then we have the clean title and the clean text column. Thereafter, we are having the clean title and the clean text. We have concatenated both so that we get a textual data combination of both title and text. On this basis, we are going to predict whether it's fake news or it's a true news by training our model. So this is the combined clean text and title column that we are having here. And this is all of the data frame we are having after doing the data cleaning. And of course, I want you to know the that we have removed the stop words a and the two from this data set as well, that we are getting, sorry, data set I said, from this column, and from true news as well. We have removed punctuations, we have removed uh, stop words, and we have converted everything to lowercase, as you can see. So this was the cleaning and pre-processing, some little bit of pre-processing that I did. And the unique words count, you can see, have reduced. And you have to know this is for combined text and title. The unique words we are getting are 1,03,081. But earlier, for only the text, we had around 2,93,553 unique words. So this is quite huge reduction in the useless data that we have converted to our most to our useless data, and is removed, and mostly we are having the useful data by now. So for the true news as well, it is true, and we have reduced the unique words to 80,989. Earlier, they were around 1,78,503 words. So this is quite a good reduction. And moving on to the data pre-processing and the feature creation steps, what I did and why I choose these tools. Basically, first of all, I have chosen spaCy, and it's in core web large package. Basically, spaCy is an open source, similar to nltk. Similar. It's a library of nltk only, and you can install it using the commands. And basically, why I have used spaCy over here is because it provides me number one, 300 dimensions to my textual data, and it's Encore Web Large package because it has around 1 million vocabulary vectors which can be assigned. So that's a quite huge vocabulary when we are assigning vectors to our textual data. So first of all, I have, as we have to combine the, we have to convert this textual data to vectors so that we can feed it to our model. We have used this single column, that is combined clean text and title, and x underscore combine we have assigned to it, and further we have used this encode web large package to convert the textual data to a uh, vector field or a vector token, I would like to say it here. So by after feature creation we are having around 300 dimensions for our um, textual data. Earlier we were having only the rows of 44,898, but by now we are having 44,898 rows and 3,000 dimensions, right? Using this encode web large package. Of course, there are other uh, things that you can use, and I have also used to show you further iterations in the model training or model definition that can be used in the pre-processing, and that would be quite essential, right? So, and moving on, first of all, before moving to the model definition, I have uh, done the visualization of the high dimensional textual data for using the T stochastic neighbor embedding. So for the to avoid the overhead to the TSNE model, I have first of all reduced the feature dimensions using the principal component analysis, and thereafter passed it to the TSNE. And this is the graph you can visualize after passing it to the TSNE model, right? So this is the TSNE graph, and clear visualizations of two clusters can be seen as one for the true news is shown in blue, and for the red it is having the fake news, right? So moving on to the machine learning models and the iterations and the processes, why I have chosen the classifiers and the libraries, the tools used. So the tools used were uh, sklearn and Python. The classifier used were logistic regression and decision tree classifier. Input dimensions were vectors provided, or the dimensions provided by, sorry, misplaced a word, S over here, that vector provided by spaCy to our textual data, the 300 dimensions of the vector provided by the spaCy to our textual data, right? And the output dimensions is fake or is true. Training data is kept to 80% and the testing data to 20%. So why I have used these classifiers, or you can say this model of with logistic regression first of all, and then with the decision tree classifier discussing about them. Basically, it's a binary classification problem. So either it's to be or not to be. So for that reason, the first classifier that came to my mind was the logistic regression, where you don't have to do much of the work. And then coming to the decision tree classifier, uh, first of all, its cost is quite low, and it it forms a kind of a decision tree, and at each step it makes a decision whether it's going to be or not to be, right? So we can set its you can say attributes to get our accuracy, and of course it requires minimal pre-processing as in our case, and for that purpose I have used decision tree classifier as my second classifier. And model evaluations are done on the basis, and I have used each of them and shown each of these that I have mentioned here, that is incorrect predictions, confusion matrix, true positive rate, true negative rate, false positive rate, false negative rate, classification report, accuracy, F1 score, and heat map of the confusion matrix for each of uh, the model, you can say. And you can, I have created a separate function for it, and I'll be sharing the link of the notebook so you can see it over there. So here you can see our input dimensions for the features provided by the spaCy, and here the in the iteration 2, I've changed, as I told you, I have done something different to the spaCy and the input dimensions. Here, I have used the CountVectorizer first of all to tokenize the textual data, and I am not using the, you can say, the spaCy vectors over here. I am using a different pre-processing tools, right, that are the CountVectorizer and the TFIDF transformer. So basically the CountVectorizer does is it gets the textual data and converts it into uh, tokens or some vectorized features, and TFIDF transformer removes basically the useless information, or you can say it is for the information retrieval process that I have, useful information retrieval that I have used it for, right, and passed it on to the classifier. So these are used in the pipeline that we are creating, and we aren't doing much pre-processing here. The CountVectorizer, the TF-IDF transformer, these are all mentioned in the pipeline. So we need not do much pre-processing over here, right? So output dimensions remains the same, and the testing data is 20%, and the model evaluations are same as were the previous. So coming over to the accuracy F1 score and the heat map, for the iteration one with specific features, we got an accuracy of 97.13% on the logistic regression and 97.01 of the F1 score. And for the iteration 2, I got an accuracy of 98.93% on this data, testing data, I am saying, and 98.88% was the F1 score for this logistic regression. Coming on to the decision tree classifier, for the spaCy features, that were the 300 features, I used basically I got an accuracy of 89.29% and 88.63 was the F1 score. Coming on to the iteration 2, that was for the CountVectorizer and the TFIDF transformer. So that it gives me an accuracy of quite good number, that was 99.63% and F1 score of 99.61%. So this was all about the machine learning models. Moving on to the deep learning algorithms. Here also, actually, I have a very basic knowledge for the deep learning algorithms. So I have kept it to very simple. And though there are more techniques that can be used for more accuracy and F1 score, but I have restricted myself to a simple neural network. So moving on here, the tools that I used is Keras and TensorFlow and sklearn for feature extraction. Right? And model that I have used is sequential model. Layers that I have used are three. There are three layers. First of all, with the input dimensions as 1000 with 100 cells, the hidden layer or the intermediate layer having 50 cells with ReLU as the activation, and the output layer having a single cell and the activation as sigmoid, right? So here the unique thing to notice the 1000 vectorized features for the that we are providing to our model, right? And these are vectorized again by the CountVectorizer, and the training data is around 70%, testing data is 30%, and validation data is around, I mentioned 20%, but it's around 50% of the testing data. I misplaced it, but it's 50% of the testing data is kept for validation. That is um, around 6,000 of the samples are kept for validation. So, and the model evaluations remains the same. So dense layers, uh, the dense layers with input dimensions as 1000. You can see this was after the model summary. We had around 1,05,201 parameters, and for this was for the 1000 input dimensions. And similarly, coming, I have decided to create another model using more number of features and to get the accuracy. And a similar model, but with 10,000 vectorized features, I have chosen. But the approach remains the same as was for the deep learning algorithm one, right? And this was the summary, model summary that we did, and other parameters are discussed, of course, in the final that the final evaluations that I did and final results that I got. I have made a separate table for that, and we'll be getting to it shortly. But with this 10,000 features, I had around the total parameters of 10 lakh 5,201. By this, we come to the results of each iteration, first with the 1,000 features and the second with the 10,000 features. Here I have used the CountVectorizer for the pre-processing task and not the spaCy, of course. And again, we are getting a quite good accuracy, that is 99.146% on the testing data, and an F1 score of 99.10% for the 1,000 features that we are having. And we have increased the accuracy and the F1 score by 0.01% after increasing the feature count to 10,000. So coming to the overall comparisons or the final results that we have for you is the logistic regression, first of all, gave an accuracy of 97%. Then decision tree classifier with specific features gave an accuracy of 89%. So first two were for the specific features, the other the logistic regression 2 and the decision tree classifier 2 with the features provided by the CountVectorizer and the TFIDF transformer to the model. So we're getting a quite good accuracy using the CountVectorizer, that is around 98.9% for the logistic regression and around 99.6% for decision tree classifier in classifying whether it's a true news or a fake news. And in the artificial neural networks, it's more around 99.11%. And of course, there can be more modifications that can be done, more number of epochs can be there, more number of we can vary the batch size, and we can change the optimizer here. I'll discuss more about the optimizer that I chosen in next. And this was all for the overall comparisons. Of course, there can be the accuracy can be increased further, and also the F1 score. But I thought that this was quite good for the model in classifying whether it's a fake news or a true news. So I have restricted myself to this. And this was the test set accuracy that we were getting. And these were the F1 scores for the model that we were getting. For each model, I have plotted this bar graph, and this is the final results that we got with each model and the iterations are that we have used. So first, for the model with logistic regression, the iterations I have kept it to 200, and thereafter the features here are the spaCy vectorized features that were provided by the spaCy that were around 300, right? So this gives me an accuracy of 97.14% and 97.02% of the F1 score. While the solver, I have kept it to LFPGAs, and the everything keeps everything is kept similar in the second as well, but the input dimensions are changed here, and the features from the CountVectorizer are passed on to the model. And same does for the decision tree classifier. I did it for the 2 times and got quite good accuracy of this, right? So around 99.63. And here I would like you to note that parameters that I have chosen were criterion. I have set it to entropy and max depth of the decision tree is kept to 10, and splitter, basically what decision tree does is it splits at every step. At every step, it makes a choice and it splits. So for the best split, we have chosen the splitter to best and the criterion to entropy, and the random state, that is the randomness of the estimator, is set to 2020. Same for the decision tree classifier for both the input features, and for the neural network we had around batch size of 512. With 7 epochs we are getting an accuracy of 99.14%, with optimizer as Adam and loss as binary cross entropy. So basically this was because it was a sort of binary classification problem. So for that reason, I've chosen the loss as binary cross entropy in both the cases, and you can see around 0.01% of increase in the accuracy as well as in the F1 score. So these were the final results of a model, and the best that we can get was around 99.63% of the accuracy overall from the decision tree classifier with the CountVectorizer as its input features provided, right? So that was all for my 4 weeks that I was doing, and I would like to thank IBM and Coursera for providing me this opportunity uh, for uh, moving more towards machine learning, and especially towards problems like these that are the basis of a real world problem, right? So in here I would like to discuss my timeline. In this first week I did more about explored about the use case and how it's working, how it's doing. Then after I discussed on the dataset, and there was a lot of brainstorming done as well, whether to choose this column, this not, or what need to be done. Right? So moving on to the second week, I did the ETL process, the feature engineering, the data cleaning, the data pre-processing, the data visualizations. Each was done in the second week, and in the third week, I did more of the model training and model definition. And in the fourth week, I would say I did the model evaluation side by side for each model and compared every result and the final results I have shown you in the previous slide, and deployed it through the Jupyter notebook provided by IBM Watson Studio. So that was all. I was Anshul Gupta, and thank you. Thank you for being a lovely audience. Thanks a lot.